This is the final part where we are looking at the variance and standard deviation of coded data that comes from multiplication. So suppose this example where a taxi driver charges a fixed charge of $3 plus $4 per kilometers. So if they travel X kilometers, the cost will be 4 times X plus $3, which is fixed. And that's the data points that you get, 7, 11, and 15 for the X's of 1, 2, and 3, the distances of 1, 2, and 3. When you look at 1, 2, and 3, that's your original set of data. And you can see that the cost is coded data because there has been some things that have happened to it, multiplication and addition for that matter. And if we take a look at the variance between the two, we see that it is slightly different. And we show this with the diagram. As we said, the variance is how far spread out the points are from the mean. And if you check it out, the original set of data, okay, has its mean at 2. And it's just 1 unit on either side spread out from that mean, which tells you that the variance and standard deviation should be less. And then when you multiply it by 4 to get 4x, get this green pieces of data, you see now that the average is here, but the spread has increased quite a bit. It has gotten further apart, 4 times further apart for that matter. But if you add 3 to it after that, you see that it remains the same. So this is your mean now of the coded data after you multiply by 4 and add 3. But you see that the spread away from the mean is the same as what it was for the green. And we know this because we did this in the last lesson, where coded data, when you add a constant, does not make a difference to the variance and standard deviation. But multiplying does, because the initial step from the blue to the green did increase the spread. So how is that coded data that you multiplied related to the variance? We get this. So adding the constant does not make any difference to the variance, meaning variance of x alone will be equal to the variance of x plus 2 or x plus a for that matter. We did this in the last lesson. But when you look at the variance of ax, these are not going to be equal to each other. How are they related? The variance of x will equal to 1 over a squared of the variance of ax. Meaning you divide the variance of ax by the square of the constant that's multiplied to it. And when you're looking at the standard deviation alone, standard deviation of x is equal to just 1 over a times the standard deviation of ax. Because remember, we said the standard deviation is the actual absolute representation of the distances to the mean, while the variance is the squared distance to the mean, right? And that's why when you are finding the standard deviation of the original data in comparison to the standard deviation of the coded data with multiplication, you will just divide by a, because this 4 space difference, just divided by 4 to get that 1 space difference, because standard deviation is what is actually showing. Variance is the square of that, right, which we use to make it positive, if you remember. And so that's the relationship between these two. For general ungrouped data, your variance of x, which we said was the mean of the squares minus the square of the mean, is equal to 1 over a squared times the mean of the squares minus the square of the mean of that coded data that's there, where a is the constant that's multiplied to the original set x to give you that coded data when it comes to multiplication. For group data, similar thing, where the only difference here is that our x will be our estimate, right? It will be between and the middle point of the class. Next, we look at an example where the standard deviation of the prices of a selection of brand name products is $24. That's the standard deviation. And imitations of these products are all sold at 25% of the brand name price. And we have to find the variance of the prices of these imitations. So we had that the standard deviation of x is equal to $24. And we know that the original products are sold at the price of X, while the imitations, or the copies for that matter, are sold at 25% of that price. So a quarter of that price, 1/4 of X. Then we are told to find the variance of the imitations that are there. So we know the variance of the original sets of data is just that $24 squared. So variance of X is just equal to 24 squared, which is just $576. And if that's 576, and our constant A is equal to 1/4, then to find our variance of 1/4x, that will just be A squared multiplied by the variance of X. This is going to be just 1/4 squared multiplied by 576. And this gives us $36. So $36 is the variance of the prices of the imitations using this formula here, where the variance of AX plus B, where here A is 1/4 and B is 0, that is equal to A squared, which is a constant multiplied to get that coded data, which is 1/4, times variance of X, which we got to be 576 by squaring the standard deviation. Finally, given that the sum of 3x minus 1 squared equals to 9136, and the sum of 3x minus 1 equals to 53, and n is 10, find the value of sum of x squared. So remember, the variance of x is equal to 1/a squared times the variance of ax plus b. Firstly, we need to write out what this formula is. Expanded mean of the squares, x squared over n, minus the square of the mean, x over n squared, is equal to 1/a squared times the sum of the squares over n minus the square of the mean, the coded data. And that's going to be our formula in expanded form. We know what this part of the equation is, all of it. And we know what n is here. We need to find sum of x squared. And we can find what the sum of x is as well. Where firstly, the sum of 3x minus 1 is equal to the sum of 3x minus 1 times n. Therefore, that 53 is equal to the sum of 3x minus 10, which gives us that 63 is the sum of 3x. Then if 63 was a sum of 3x, then the sum of x will just equal to 63/3. Because if each piece of data was multiplied by 3, then those were summed. We can just divide by 3 on all sides to get what the sum of the original data is, which is 63/3, which is just 21. Then, after all the information that we have, put it into this big formula, and we get that the sum of x squared over 10 minus the sum of x, which is 21/10 squared, is equal to 1/a squared, a which is the constant that's multiplied to x in the coded data, which is 3. So 3 squared times the sum of 3x minus 1 squared, which is 9136/10, which is n, minus the sum of 3x minus 1, which is 53/10 squared. What this will then give us is the sum of x squared over 10 minus 4.41 is equal to 1/9 times 913.6 minus 28.09. And from this formula, if we solve for the sum of x squared, we get 1028. And that's going to be the value of x squared given all of this data.